right, so we're walking through the chapter 15 big quiz, starting with problem number 1. Find the volume of the solid in the first octant, bounded by y equals x plus 2, z equals 9 minus x squared, z equals 0, and x equals 6. On yours, I gave you a hint. Last year, I did not give them a hint. On yours, I said be very careful. We're hunting rabbits. Okay. Be very careful about the y's for your bounded region. You know what? I don't know if I have I'm just going to draw it from scratch, but I might just have it right here. There it is. Okay. So here's the thing. Y equals x plus 2 is a line. Everyone, we all have that, right? Okay. X equals 6 is this vertical line right here. But the problem is it's also bounded by z equals 9 minus y squared. And if z is 0, remember it's got to be in the first octant, so z has to be positive, right? If z is 0, that means y squared equals 9, and it means that for z to be positive, the y has to be between negative 3 and 3. The y can't go above 3, because if the y goes above 3, your z becomes negative. So you have to chop off the y's at 3. Because you had to chop off the y's at 3, now, you know, honestly, I don't know why I chose to do this with 2 integrals top minus bottom. I could have easily just written this as x equals y minus 2 and done a right minus left, but, you know, whatever, right? Okay. So anyway, either way, so I did it with 2 integrals. So first octant, so we have from 0 to x equals 0 to x equals 1, and then you have your y equals x plus 2, and then from 1 to 6, going up to your 3. So anyway, of your 9 minus y squared divided by x. So anyway, that is why. You know, honestly, I don't know. Maybe doing it dx dy wasn't, I don't know if that was easier or harder. But it could be done. It could be done with 1 integral. I just haven't tried it. But that was my setup. So there will be one on your test. Now your test, if I remember right, is like right around 10 problems. So I'm going to tell you now. And there's a hint on your test also that says warning, look at your y's. So if you see a hint and it says warning, make sure you take a close look. You should heed the hint. Yes, go for it. How to do this with triple integrals? It'd be the same thing. It's just your z's would go from 0 to 9 minus y squared, and then you'd have a dz dy dx. Yes, today. Yeah. You have the setup right? Well done. Good job. Okay. So. Okay. Oh, whoops. Why do I have it? Oh, you know what? You do have to do it with 2 integrals either way. I did do it with 2 because it's cut off by the y-axis, and so because it's cut off, if you do a right minus left, you have 2 different lefts. You have a lefty and another lefty. So no matter whether you do dy dx or dx dy, you're doing 2 integrals or 2 sets of integrals. Okay. All right. So Tajesh. Oh, I don't even actually show it. I'll walk you through. Did you do it with the dy dx, this one? Okay. So let me move this stuff down. You know, I'm going to move this down too and work right below the integral. Give myself lots of space. So for the first one, we're going dy. So we have the integral from 0 to 1 of 9y minus 1/3 y cubed from 0 to x plus 2 dx plus 1 to 6, 9y minus 1/3 y cubed from 0 to, 3, dx. Okay, we good so far? All right. So plugging in, so we have 9x plus 18, just plug in the x plus 2 there, minus 1/3 times x plus 2 cubed, and then minus 0 is just 0. So this whole thing, dx plus integral 1 to 6 of 27 minus 18, no, let's see, 27 divided by 3, 9, 27 minus 9, yes. Yeah, so the answer is 18. Okay, so do we match up so far? Yes? Okay, good. Let me give myself a little more space. You know what, I'm going to just do this. Edit, undo. Don't you wish when you were writing you had an undo? Okay, group. Okay, there. All right, so next line. So we have, now we're dx, so 9 halves x squared is 18x. So this would be 1/4 times x plus 2 to the 4th, so minus 1/12 times x plus 2 to the 4th, all evaluated from 0 to 1, plus, this is 18, so 18x from 1 to 6. All right. Do you see it?
I just expanded the entire thing out. So like I did x plus 2 to the cube and I expanded that, and then I did the integral.
Which it should still work.
No, I think I messed up my terms when I was expanding.
Oh, don't expand though. X plus 2. As long as your argument is linear, you just do a regular antiderivative and divide by the slope. Yeah, and if the slope is 1. Wait, what?
I know you can do that. You can't do that.
Sure you can. You guys did not have me last year. Oh, you had me though.
I didn't.
Oh. Wow, little trick. This is actually going to be important on your test. There's one problem that the very first time I taught this class, so first semester last year, there was a problem on the test where if you do the integral keeping things grouped like you should, it's really not hard. It takes like 3 or 4 lines and you're done. And I had almost everyone, like out of a class of 30, I think 29 students all expanded all the polynomials out, right? So there were cubes and 4th degrees and all this. And so literally students kept coming up to me asking me for more paper. And I couldn't figure out why everyone needed more paper when I gave them a whole sheet for this problem. And it's like 4 or 5 lines. And it was because they had like multiple lines for one set of polynomials that they're trying to combine like terms for. It was so horrendous. And afterwards I'm like, oh my gosh, guys, don't you remember that if you have the integral of, 3x plus 5 to the 7th, right, that it's just 1/8 times 3x plus 5 to the 8th divided by 3, right? So, yeah, it's just a u sub, right? But you're just doing the u, like, it's just a shortcut u sub. So if your argument's linear, you just do your regular antiderivative, but you can divide by the slope. So it saves you some time. So you end up with, like, this would be, to clean it up, 1/24. That says 24. 3x plus 5 to the 8 plus 3. Yeah. It just saves you the u sub time. Yeah. Yeah, let's go back to the actual problem. So that's a good thing to know before Wednesday because it'll save you, like, honestly, 45 minutes of working on one problem. All right, so Anyway, so from there, do I have the numbers down here? Yeah. So like there's, if you take this and continue right here in this line, that should equal it up. I don't know. 1 plus 3, 1 plus 2, 3 to the 4th, 81 twelfths. Yep. Plus, and then 0, 0, 2 to the 4th, 16 twelfths, but it's minus negative, so you get plus. And then here, 18 times 6 is 108 minus 18 times minus 18. Yeah, it's the exact same. Yes?
Could you overhide up the diagram for the dy dx?
For this one?
Yeah.
Yeah. So, when we are bounded, y equals x plus 2, that's just literally this line right here, right? Y equals x plus 2. Yeah. Okay. So that takes care of that one. This one, x equals 6, pretend that's straight. That's that line right there, right? Okay. So the problem is, okay, and then z equals 0 is just the whole plane here, right? So that doesn't matter. But the z equals 9 minus y squared. So because it said it had to be in the first octant, and there will be problems on your test that say first octant, that means the z has to be positive, right? So well, if we find where z is 0, z is 0 wherever y squared equals 9. And if you just think about it, if y is anything bigger than 3 or less than negative 3, which doesn't matter because we're first octant, so bigger than 3, you're going to get a negative z. So y has to be below 3. So you have to cut this off by the line y equals 3. That was the trick. Yes, Jack?
So what's a way to standardize the checking process for each question? Check whether our bounds produce the z outside of the region we're talking about.
I always just sketch all the boundaries. If there's a z, if it doesn't say in the first octant, then the z is irrelevant. It's only if it says in that z has to be positive or something like that, that your z might create a boundary where it intersects the xy plane.
So
then you set your z equal to 0.
Then you have to check.
All right. Oh, and if it's saying find the volume, that's a problem too. Because if it just says find the integral, you're fine, whether you have positive z's and negative z's. If it says find the volume, then you got a problem too, because you need to only use you have everything has to be positive, and if there's negative z's mixed in there, they will subtract from the volume instead of adding to. But I didn't give you anything like that, so there's nothing like that on your test. But it's kind of like the area thing before. If I say find the integral, that's fine. But if I say find the area and you've got stuff above and stuff below, then you gotta bring the below up. All right. So this one, evaluate the integral from 0 to 2 of the integral from y squared to 4 of root x cosine x dx. So does anyone know the antiderivative of root x cosine x? No. So, no. What should we do instead? Switch you tend to switch your limits. This was a switch the limits question, right? So when you graph the space, so our y goes 0 to 2, our x is going from y squared to 4. So this is the space we're talking about. So to switch it around to dy dx, so now our y is going from 0 to this function right here, which if x equals y squared, then y equals root x, right? And then our x's are going 0 to 4. So you switch it around because then what happens, you integrate dy, is just this times y. And then, yeah. And then when you multiply in the root x, now you have x cosine x, right? Minus 0. So once you have x cosine x, now you can use tab method. Right? So if you have an integral, a double integral that's impossible to do, it's probably one where I'm checking to see if you know how to reverse the order. Do you guys all remember tab x cosine x? It's over here to the side if you need to review. So anyway, so you end up with x sine x plus cosine x from 0 to 4. And the final answer was 4 sine 4 plus cosine 4 minus 1. I had a couple of you who got the 4 sine 4 plus cosine 4 and forgot that the cosine of 0 is 1. So be careful when you're plugging in your 0 that you remember cosine 0 is 1. And a couple of you were just off a little bit by coefficients. So just be careful when you're setting it up. Any questions? Anyone need to see anything more thoroughly done? Okay. All right. Is this all I have for this one? Do I not have anything like worked out? I don't. All right. I will have to work this out. All I have is the setup and the answer of 2/3. Yes.
So just the volume over the area?
Yeah.
Okay.
Yeah. It's average. When you're talking about average value, it's the average z value.
Yeah.
So what is z? It's the volume divided by the area. Yep.
I remember like last year for let's say average value in this convention, it was like the area over like the
Area over the length.
Yeah.
Yeah, the width. Yep. Same kind of thing, because that was average y value.
Yeah, that was actually
Yep. And this is average z value. Yes, Jen. Sure, of course.
It's like 1 over 0.
Okay. Guys, if you made silly mistakes, do not beat yourself up. It was the 4th period of the Tuesday before Thanksgiving break, right? Yeah.
Free drop.
I'm not getting a free drop, but I will do a drop, right? So I will drop the lowest quiz. All right. Does anyone need me to work this one out? I'm happy to do it. Yes. Absolutely. So average value of a z function is the volume, if you were to find the volume over this region, divided by the area of the region. So you, like, if this is our region R is this little triangle here, right? So you find the volume of your z equals x squared plus y squared that's like floating over this region. So you do your normal volume formula, and then you divide it by the area of your region, which is a half.
Oh, okay.
Any other questions on this one before we move on? We have a lot of questions covered. Ben, you okay? Yeah? This one, honestly, had the highest, like, correct, how do you say that? Highest percentage of students who got this correct. Like, you guys rocked this one. So, which is funny because it's all letters, right? For some reason, you guys like working with letters. So, yeah. It's the arithmetic. So, anyway, so find the volume of the solid in the first octant. Now, to be fair, the region you were over was a rectangle, so it was a pretty simple one, right? So anyway, when all is said and done, that's your final answer. A couple of you were wrong, so make sure you check your setup. I can't show you both the setup and the answer at the same time, but feel free to talk to me. You had to solve, by the way, to solve for z. Right?
I
Oh, and you forgot to multiply the p back in?
Well, I forgot to even put it in the first place.
No. Okay. All right. Anyone else have any questions about this one?
Could you just scroll up real quick, please?
Sure, of course.
Could you do this with a triple integral?
That's what I'm saying.
I put in factors.
But I will give you partial credit on the test.
Oh, no.
Right? So that means, like, if you got a 2 on the big quiz, that's at least a 20, right? Plus a bunch of partial credit.
Solid like
What the other
That's a solid effort.
Yes, to Jeff.
Could you do this with a triple integral? Too?
Sure. I mean, does it really make a difference? I mean,
Yeah.
sure. Your z, since you're in the first octant, your z would just go 0 to this, and then your first antiderivative, you'd be putting it down anyway, right? So you're not making your life easier by writing it as a triple integral.
I forgot all I see on this. Yeah, when did I even get this all?
Okay. Any other questions? We're all comfortable? All right. Not comfortable, but we're ready to move on. All right. This one, I would say, if the last one was the highest scoring, this might be the lowest scoring. Well, yeah, the last one. So, okay. So many of you just found the mass, but I didn't ask for the mass. I asked for the center of mass. You had to do the whole thing. So, quiet please. So you had to find the mass, which is just the integral of the density, double integral of the density, right, over the region. So you'd find the mass. Then you had to find your m sub y and your m sub x. M sub y is the double integral of the density times y, or no, times x. That's right, they get reversed. M sub y is the double integral of the density times x. M sub x is the double integral of the density times y. You do that, you get a whole bunch of beautiful numbers. And then your center of mass is m sub y over the mass, comma m sub x over the mass. And please cancel the k's. Like, if you are so lazy that you're not going to even cancel the k's, I don't think I'm going to take it off a point. Right?
Just draw a line through it. Like,
Yeah, draw a line through it is okay. You had a calculator.
no,
Oh, you didn't have a calculator. Oh, never mind. Okay. Well, then this is fine. Right? This is fine. But you have to cancel the k. Cancel the k.
How about everything else?
You could do like 9 times
Okay.
64.
Okay.
Use your mental man? Go away.
How simplified do you expect answers to be on the test?
I accepted every single unsimplified answer that was correct.
The wrong answer.
So, yeah,
I don't even know
And you'll do that on the test?
maybe. I did a good one. You guys are nice to me. Maybe.
And then you switch concepts on the day of the test.
No, I will accept that as long as it doesn't say simplify. I think there might be one question that actually says simplify. So, did you guys have a question? Side, do you have a question? No? Okay. All right.
Wait, oh, I actually have a question.
Yeah.
Okay, so when you know when the mx and my are the same, like m sub x and m sub y, is it just like when they're symmetrical?
If you have to have symmetry over a line both with your region itself and with the density over the region.
Okay, so it's both.
So you have to have like super symmetry.
Alright, so it's like a bell curve basically. Like that's not true.
Okay.
Wait, just trick substitution this year.
Didn't I teach you trick sub? We did it for like 35 seconds. Oh, why did I teach it to you? Just so you do it. There's no trick sub on your test.
Yes, sir.
Yeah. Okay.
I thought that was like part of the student.
It was, but I didn't put it on your test. Okay. All right. Okay. Surface area. It's very similar to the old arc length formula, right? So you have your double integral. The double integral is the same every single time. But but now your integrand isn't a z function. Your integrand is the square root of 1 plus f sub x squared plus f sub y squared. This one, wow, this was so much easier if you did it in polar. So I just went ahead right off the bat and converted to polar. Remember, if you convert to polar, you have to as soon as you rewrite dy dx, it has to become r dr d theta. Don't forget the new r when you convert to polar. So I converted to polar, super easy with polar, much easier.
How did I get this one? What? I'm officially.
So the final answer, you did have to do a little u sub, but not crazy u sub, just a little u sub. So the final answer was pi 6 times 17 to the 3/2 minus 1. Well, of course it is. What is harder, having a blank quiz that you have to do from scratch in your head, or watching someone with the answer key in front of you walk through it? Come on. So much easier with me. I'm going to start you with the answer key and just ask you if you understand everything, and they'll be your best.
I still say no.
Well, at least you know it.
No, it's just a normal use of.
The 4r squared, I tried triangle.
You know why? If you don't have the r, it is trig sub.
Yeah.
But the r is what lets it be just plain old use sub.
Yeah.
Amal, you doing okay? Are you okay? Okay. All right. Are there any questions on this one? Any questions? Lily, you okay? All right. Okay. Use a multiple integral and a convenient coordinate system. I love this problem. This is from our old book. I copied it straight out of the book. Our old book used to say use a convenient coordinate system, and then it would almost always just be rectangular. And you're like, oh my gosh, why isn't this, what else would it be? And it's just a regular old, plain old. Yeah.
Spherical.
I thought it was a typo.
Nope.
I thought you did this.
it's
But then
literally-
the previous problem, it actually wrote that.
Okay. So anyway, this one very straightforward. There was nothing unusual about it. You didn't have to cut anything off. It just was what it was. So anyway, so the answer was 27 halves. This one, most of you did well on. There were a few arithmetic errors. I saw quite a few arithmetic. If you missed it, it was probably from arithmetic.
This is why we did the best of the movie.
Yep. Any questions on this? Does anyone want me to walk you through how to set it up or how to evaluate? Danny, you okay? I can't hear you. You good? Yeah? Yes, Ben. That's fine. Triple integrals are fine. Honestly, triple integrals in rectangular are just double integrals with the z put up to the top. I mean, there's really not much else to it. Just go backwards to the double. I know. The first step in the triple is just going back to the double. So. All right. Okay. Jacobian. So most people got this. Most. If you missed it, there were a variety of mistakes. So one mistake I saw was one student for the dy du, dy dv, instead of having 1 and 1, they had u and v, or something, v and u or something like that. So be careful about your partials. One of you, okay. I don't know who this is, so don't think I'm trying to single you out, because I'm not. But one of you messed yourself up with your own handwriting on this one, right? So, like, one of you had the exact right answer, and your you, I don't know who this was, but your you, like, you thought it was a 4.
What?
Because it kind of went like that, kind of, right? And so it had you all the way through, but then I think right here, they thought it was a 4, and I would have still, like, I wouldn't have known if they had it, like, kind of written kind of 4-ish, right? I would have taken it, except then they combined and wrote it as a 5, like they combined terms, and so then there was no way to take it, right? So anyway, so please be careful with your handwriting. U's and Z's look so much alike. You gotta be so clear when you're writing all your U's and your V's. So please be careful with your handwriting.
I can't do that. Impossible.
You can have good handwriting. Was it you?
No, I'm just saying, like, I can't control my handwriting. It's a monster. Like, my hand on the paper, my hand on the paper. I can't.
I don't know why, but I was like, it's the W, and then how
All right. Okay. Was 9 the one that everybody skipped?
Oh, yeah.
All right. Oh, and 10. 9 and 10. Don't forget, little hints for your test. It just makes it a little bit easier if your parallelogram doesn't intersect the origin. If it's like over here, you have the right to shift it down to the origin, as long as you shift everything else down with it. So this one was fine. Like, this one was already. So anyway, so find the volume of the solid above that whole nice, lovely function, and below, bounded by that z, and then below by r. R is a region bounded by the parallelogram, right? So whenever you have a parallelogram, you know you're going to be doing a Jacobian. It's just the easier way to do it. So you could, like, it didn't say use a Jacobian. You could have done this without Jacobians, right? You just have, and it's not terribly hard. You'd have to set it up with 3 separate, double integrals or triple integrals, depending on how you do it, right? So anyway, so using the Jacobian, you find the equations of your 4 sides, right? Write them in standard form or some sort of a form, so all the x's and y's are one side. I need to get in the habit of writing in true standard form, which is ax plus by equals c. I tend to just write it however it looks good. But anyway, so there's that. So then I let my u be 2y minus x. Some of you might have u as x minus 2y. It's completely fine, right? Makes no difference. And then my v was 2y plus 3x. So anyway, so there's my u's and my v's. You can have the u and the v switched. You can have the stuff in here switched around. We'll all end up at the same place. So anyway, so you find your u and your v, and then remember you've got to solve for x in terms of u and v, and y in terms of u and v. So what I always do is I take my u, I solve it for x, I take my v, I solve it for y, and then I plug the y in for my y in my x, and then I get that, and then I plug that in for the x in my y. So, and do a little substituting, and you end up with x equals 1/4 times v minus u, and y equals 1/8 times v plus 3u. Once you get that, you find your Jacobian. I ended up with a Jacobian of negative 1/8. Depending on how you had your stuff, you might have ended up with positive 1/8. There are other Jacobians. If you ended up, I think, with like a 5/8, that was also correct, depending on how you manipulated everything. But don't forget, when you do your actual stuff, that you have to use the positive Jacobian. So if you get a negative, it's the absolute value that you put in, right? Okay, so you got to rewrite. So my z look at that. There's my v, there's my u. Life is good. So my z was equal to v times u to the 3 halves. So I replace my z with v times u to the 3 halves. My Jacobian dv du, and then remember right up here, so if this is my u is going from 0 to 8, my v is going from 0 to 16. And then once you do all that, then the integral should be fairly simple to do. This was kind of a big one. One on your test might also be fairly big, not like crazy, but you know, similar. So anyway, so the final answer, a lot of you got 32/5 times 8 to the 5 halves, which was correct, or 40/96 root 2 to simplify. Yes, Dorsa.
So on the test, are you gonna have more papers than this?
On the test, I give you a full sheet for every question.
How many questions are there?
I think 10. There might be 11.
Miss Price, do you really think the entire hour is enough for the test?
Part 2?
So the entire hour is enough if you don't expand all your polynomials on that one problem. So first semester last year, and nobody finished, right? And so I said, all right, I will give you another 10 minutes to finish up tomorrow. And I remember after collecting them, almost everybody was on the same one problem. And so the next day I handed back, I let everybody have 10 more minutes, and 10 minutes go by, 20 minutes go by, 30 minutes go by. By 40 minutes, people are starting to turn in the test. And I start looking, and it's all because of that same problem. So all I'm telling you is you don't have to expand your polynomials to integrate them, because that will take what is a 7-minute problem and make it a 45-minute problem. So
Even if you didn't build it in little trick, then you technically just do some power.
yeah, except the problem was you had different polynomials all in one integral. So you would have had to do, like, divide the integral, like you'd have to do a u sub and a w sub and a q sub, and like you'd have to do a bunch of different substitutions within the same problem.
But it was like all additive.
You what?
It's all just like added together.
Yeah, you could have. But gosh, don't. Yeah, I mean, honestly, if you just know, like, whenever I could have sworn that we all learned, like, if I'm doing, for example, the integral of 1 over 3x minus 7, right? I know that that's ln absolute 3x minus 7 over 3. Yeah, it's always, whenever your input is, your guts are linear, you just divide by the slope. It's just normal antiderivative divided by the slope. Saves you so much time. Okay. Is this the last problem?
Unfortunately, yeah.
Unfortunately.
Right?
Okay. Find the mass of the sphere x squared plus y squared plus z squared equals a squared sphere where the density at any point is proportional to the distance of the point from the z-axis. Okay. All right. Remember that mass is essentially it's like the integral of the density, right? Okay. So here's the thing. Your density, how do I say this? It's the distance from the z-axis. Distance is perpendicular to whatever you are finding the distance from. From the z-axis, if we go out perpendicular in any direction from the z-axis, what distance is that? That's r. That's r. So your density is my density is proportional to the distance from that point to the z-axis. So density equals kr. So I went to first to cylindrical, and then it looks like I converted to spherical. So anyway, could I have done this in cylindrical? I think so. I don't know though, with those square roots of a squareds minus r squareds, it's kind of a pain. But I don't know. It probably would have still worked. I think it would have still worked. I don't know. Yeah, I think it would have still worked. Yes, to convert from cylindrical to spherical. All right, so that lovely picture doesn't answer all of your questions. Okay.
I'm just confused with spherical. I just don't understand spherical.
Okay, so you have x squared plus y squared plus z squared equals a squared, right? Which means a is the radius of your sphere, not a radius, like r in polar is straight out from the z-axis. Polar is two-dimensional, right? Cylindrical is two-dimensional with a z, right? But spherical is, spherical, right? Okay, so anyway, so your a is the radius of your sphere, right? All right, so if we have okay, so this is me drawing like in an XYZ plane. So if we were doing this in cylindrical, then we would have like our base region on the bottom would be surrounded by the circle, just x squared plus y squared equals a squared, right? So we're going from negative a to a, and that, so we're in polar. So anyway, so our r goes from 0 to a, our theta goes from 0 to 2 pi, and our z, then you would just solve that original function for z, right? Square root of a squared minus r squared, negative to positive, square root of a minus r squared. Which you could just double this and get rid of that and make that a 0. All right, in spherical, the theta is what makes you go around this way, right? So the theta is still going to be 0 to 2 pi. Our phi is the angle made with the positive z-axis, right? So we start from here and we go around. Well, if we want the whole sphere, which we do, then we have to go all the way from here to here, right? So our phi is going to go from 0 to pi, because we're pi away from the top at the bottom. Because phi will never go past pi, ever. Like the theta is what makes it go around. Phi is how far out you're going this way. Am I going a little bit? Am I going all the way? Phi is like your cross section, just like, how do I say this? Like if I kept going, I'd be overlapping myself. Yes.
So if you're usually converted from cylindrical to spherical, but you had this half of the sphere times 2, would it be pi a half square then?
Yes. Yes. And then since it's a sphere, it's 0 to the radius of the sphere.
Is theta ever not 0 to 2 pi?
Yeah, if I only did like a quarter sphere, like a watermelon slice, I don't know, like, I mean, you know.
I don't think we've ever done a problem like that.
Yeah, I don't think we have either. Yes?
So when it says density at any point proportional to the distance of the point from the z-axis, you're just multiplying the integrand by kr.
Yeah.
And is that always going to be the case for the density of the point?
Yes. Oh, not kr, but whatever the density is. Yeah, in this case it was kr. Are you saying is it always going to be kr? No. No. This one it's kr because the density was proportional to the distance from the point to the z-axis. So proportional means, like, is proportional to means equals k times, right? Density equals k times. What is the distance to the z-axis? R. A would be this, is A is going like out, right? R is going straight out. And when you want a distance from something, you need perpendicular distance. R is always going to be parallel to the xy plane.
If it was KA, wouldn't it be a constant?
If it was,
like R is the equation, which is why you need that.
that is true, yes. KA would be a constant, KR would be a function.
Where does R go when you put it in a spherical?
So your R, I know. Okay. So I have KR. R is the same thing as rho sine phi. R, it's just one of those conversion equations. So R equals rho sine phi. And then every time you do a spherical, it's always times rho squared sine phi, d rho, d phi, d theta. I don't know why this is down here. Whoa. Woo! Whoa. There we go. There we go. Easy peasy, right? Right, Nathaniel? Okay. So, yes, to Josh.
Wait, so like, since it's KR squared, wouldn't it be K times rho sine phi?
So this R was added to convert it to cylindrical, not to, like, how do I say this? It's not part of the actual, it would be part of the integrand if I evaluated like this, but I'm not. I'm switching over and evaluating in spherical, so I'm just going to do it. I'm just kind of rewriting it from scratch. So that R is kind of getting replaced with the new Jacobian of rho squared sine phi. All right, so final answer was pi squared k a to the 4th over 4. I think someone got that.
I got it, but I didn't get the K.
Oh, yeah. Yep. Okay, I'm going to stop recording for a minute.